So let me paint a scene. Let's say that we have an application that is comprised of two applications. We have a front end and a back end. Our front end goes and actually visualizes the players and rosters from an MLB team, where our back end actually goes to the internet and scrapes them for us, returning it to the front end so we can visualize it. Now, the next logical step for me here is to deploy this to the internet and make sure people can actually go and use it, especially my friends. But as we know, most things in life aren't really free, especially when it comes to computing resources. It is really not free and it can get very expensive. So what happens when I do have friends that tell more friends that tell more people, and then they start to come to my website and I start to get a ton of traffic? More computing resources start being used, that's for certain, and what can happen is eventually those computing resources will run out. So if I'm hosting my app on just one server or one computer, eventually the more people come in, the more CPU memory is going to be used, and it's probably going to crash my app and people aren't going to be able to use it. So we really need a tool that runs health checks to make sure our app is consistently up and running, allows us to scale it out to make sure we have multiple servers running our apps in case one fails, allows it to heal itself when it does crash. And the good news is that tool is available and it's called Kubernetes. Now, there are a ton of ways that we can learn about Kubernetes and I can teach you, but the idea here is to make it very practical so you guys can take the knowledge and essentially run with it for yourself. Now, we're going to get hands-on and deploy an app from beginning to end in Kubernetes, but before we do that, it's important that we cover the concepts of Kubernetes so you're not left wondering how all this magic happens and you can actually have the power and control to go do it yourselves. So let's jump right in. All right, let's break down the cluster architecture real quick. So a cluster you can kind of view as a city if you want to use a reference, right? And it's the overarching concept in Kubernetes. Now that is made up of two kinds of nodes. You can kind of view the control plane as like the mayor's office or essentially just the orchestrator, right? It handles everything that comes into it, people's complaints. It stores information about the city, about the residents, all that stuff. So if we look at it from that perspective, the Kube API server really serves as kind of like that main communication hub where information is constantly flowing in and also talking to other components. So the etcd is kind of like our memory store, right? It knows everything about our city or cluster. It also knows things about the nodes individually, but what's important is that it's going to maintain the overall state of the cluster and then pass it to the Kube API server to make sure everything's going to be all good. Now the scheduler, you can kind of view the scheduler as like the city's planner, right? It makes sure that if a new resident's moving in, it has a place to go, for example. In this case, it's a pod. So a pod is our application that runs on worker nodes. And the worker nodes is kind of like an individual building, right? It houses our application. And the scheduler makes sure that our app can run on that specific or be in that specific building, right? And a node in this case is just a virtual machine or a physical machine. You can have multiple nodes, so we could have multiple buildings or multiple VMs or physical machines. The kubelet, however, you can kind of view as like the caretaker of the building itself. So make sure everything is up and running and make sure it's clean and make sure that it's healthy and assigned to the proper building, right? So it's just kind of the caretaker. The kube proxy, however, is more of like the communicator. So make sure the pods can talk together and make sure that the applications can talk together and also talk out to the internet. But it communicates with what's called a service, which we'll talk about as well. In synopsis, I don't want to go too deep into the architecture because I know I can lose people. But essentially what I want you to know is the control plane's really the brains of the operation. The worker nodes actually run our apps for us. And if you're running something in the cloud, you're mostly going to care about the nodes, the worker nodes, which is where your pods and applications are being run. However, it is important to know what the control plane does. And if you want to dive more into it, there's a bunch of great free resources out there. So go and check those out. But let's start to get our hands dirty and build a cluster. Okay, so before we go anywhere in terms of creating a cluster itself, let's talk about the project structure that we're going to be working on today. So in the last couple of videos, we built an MLB roster web application that's very straightforward. It's essentially a front end or user interface that allows us to click a team, make a request, and then it reaches our backend API that's written in Python, scrapes the internet, and returns us back a bunch of MLB players. It's pretty darn simple, but the goal of this is to teach us more of the concepts. So if you look at this repo, which is on Sean P. Pitt's roster app, you're going to see that this repo entails a backend, a front end, and Kubernetes resources. So I give you all the prerequisites to be able to locally install this, to run it locally, and then I'm also going to show you how to run it in Kubernetes, which I will document post video. So the first thing we're going to do is we're going to pull this down. Now I already done that, so if I go into cd code roster app, you're going to see that I have 3 different directories: backend, front end, and Kubernetes. Now, just for basics here, what we need to do is we need to create a Kubernetes cluster to start off with. We actually don't even need to interact with the app at the moment. So what we're going to do is we're going to go over to Minikube and we're going to go to Get Started. Under Get Started, you're going to see that there is some prerequisites that we'll need, such as 2 CPUs or more, 2 gigabytes of free memory, 20 gigabytes of free disk space, blah, blah, blah. Now, I'm on Mac OS and I'm running the x86-64 architecture, so I've gone ahead and ran these 2 commands to download the binaries. Now, the next thing you're going to see is that we need to start our Kubernetes cluster. What I have done is I've run minikube start, and then you'll see I passed 3 nodes, and I named this profile in Minikube, which is called MLB roster, and I'm using the driver of HyperKit. HyperKit is a hypervisor that runs between your OS and the host on your Mac, for example. So in this case, when I created this, you're going to see that when I run kubectl get nodes, and this will take a few minutes to start up for you, but you're going to see that I have 3 nodes. I have my control plane, I have my MLB roster, and I have my MLB roster M03, M02. So essentially, this is my control plane like we talked about in the architecture, where it's kind of the orchestrator. The MLB roster 02 and 03 nodes are going to be my worker nodes. These are going to actually host my applications. So now that we have that squared away, what is the Minikube profile? Well, if we run Minikube profile list, you're going to see it's essentially the name of our cluster. So in this case, the profile is the cluster name. And since it's MLB roster, you're going to see it's running, it has 3 nodes, and this is how we interact with it. And it also has an IP to go along with it. So next, what we're going to do is we're going to look at the Kubernetes deployment for this. So when we cd into k8s, which is in the roster app directory, you're going to see that there is a deploy app.yaml and an ingress YAML. We're not even going to worry about the ingress YAML because I lumped it together with the deploy.app or deploy-app.yaml. So you're only going to have to worry about this one. So let's just look at this and open it up in VS Studio Code. So I'm going to move myself over here to the right side and let's start breaking this down. So let's start from the top. What you're going to see is this is what a traditional YAML file looks like. And this actually contains a bunch of different things, and I don't want to overwhelm you. But more or less, namespaces are a way that we can contain our Kubernetes resources. So we're going to create a deployment and services for our applications. We need it both for our front end and back end. Services are super important because it's how we interact with them from a networking perspective. So if we want someone from the internet to be able to access our service, if we want to be able to have additional cluster resources or other pods reach these services internally, or if we want to create something like a load balancer, or an Ingress, we can do that as well. And you might not know what that means, but not important right now. So more or less what I'm doing here is I'm creating a namespace called app. And this is going to have everything I need, my deployments and my services. Now, the deployment, which you'll see here, is how I actually go and deploy my application, right? I need to deploy my backend and I need to deploy my front end. Now, the image, which you'll see here, is Sean Pitt's -backend, latest. If you haven't watched my video on Docker and how to push up our application to Docker Hub, watch that first and then come to this video. So now that we have the image defined and we know that we need to reach backend port 8080, we should be good for this deployment. We're naming it backend deployment, and I'll show you how we interact with this in Kubernetes. But this is all just a bunch of stuff that we can pass, such as the selectors and labels that we want to attach with these pods or containers. So you'll see here, the other one thing to note is replicas, and replicas is the amount of instances we're going to be running of this application or pod. So if I pass 2 here, we're going to be running 2 versions of Sean backend. And this just helps disperse traffic, break up resources, and has some additional benefits to it. But we're just going to pass 1 for the sake of example here. Next, you're going to see I have another deployment, very similar, right? You're going to see that I have a front-end port of 3000, like we run locally. Our React app runs on port 3000, so we need to pass that here. But our containers is now referencing front-end, and you're going to see everything's front-end instead of back-end. So they're pretty much clones of each other, just using different ports. And then also when we make our API request in our application, remember in our app.js file, we're referencing a backend URL, but we need to pass in Kubernetes the service when we reference it. So we can't just say use localhost or 127.0.0.1. We need to use a backend, or we need to use a Kubernetes service to be able to communicate with it. So that's what's going on there. And then we have our services to actually expose our services. So what you'll see here is we have one for our front end. Our front end is where people are going to come into, right? It's the user interface, and traffic's going to funnel in through it. So we actually define this as a type load balancer. Now, if you're curious what a load balancer is in Kubernetes, you're going to see that Kubernetes has a lot of documentation around this in the network model, but essentially the service exposes an application running in your cluster to somewhere. So if we're looking at services and we scroll all the way down and I look up load balancer, you're going to see that this exposes the service externally using an external load balancer. Kubernetes does not directly offer a load balancing component. You must provide one, or you can integrate your Kubernetes cluster with a cloud provider. So you're going to see how we do this with Minikube via tunneling. But if you're using something like a cloud provider such as AWS, it's going to spin up an application load balancer for you, or an elastic load balancer. So it kind of already uses cloud resources to do this. But in our case, we can't, because we're not running it in the cloud. We're running it locally. So now that we kind of have that squared away and we know what a load balancer is, meaning traffic's going to come in and it's going to shoot out to port 3000, and we're going to have to route it somehow. Now the backend service, you'll see, references 8080 just like we do locally when we run this. However, it has a cluster IP. Now, a cluster IP only allows you to talk internally in your cluster to each other. So this couldn't be exposed out to the internet. If someone wanted to go reach my service, my backend service on port 8080, they wouldn't be able to, because the cluster IP is only tied internally to the cluster. It's not like a load balancer where we can expose it out to the internet. So now that we have that kind of squared away, let's just talk briefly about Ingress. Now, I'm probably going to do a bad job of explaining it, and I don't want to butcher it. So let's look up Ingress KDS, and I'll try to break it down from how they frame it and then what it means to us. So you're going to see that they break down terminology and what all this means, and you're going to see something like this, right? This is like an Ingress resource. And really what this does is it usually interacts with an Ingress controller, and I'm trying to see if it gives us a good definition of it, but it seems like it really doesn't. So if we look at what Ingress means, it's really collecting routing rules to govern external user access, right? So as people come into our app or our service, what happens? Where does it get dispersed out to, right? How does it get load balanced? It's really just a way of handling traffic, more or less, but there is a lot of more nuance to it than I'm probably leading on. So now that we just know this baseline, what happens when we actually deploy this file? So to deploy our application, what we'll do is we're going to run kubectl apply -f to pass a file, and then we're going to say deploy app.yaml. When we run this, you're going to see that I have a bunch of objects that are saying they're unchanged because I already have deployed this. Now, when you do it from scratch, it's going to say blah, 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 created. In this case, I deployed a namespace, created 2 deployment files, 2 services, and an ingress. So now that that's deployed, how do we interact with it? Well, if we run kubectl get namespace, you're going to see that we have a namespace called app. So if we run kubectl get pods under the namespace of app, you're going to see we have a backend deployment and a front-end deployment. Remember what we deployed, right? We deployed one replica of each of our containers, which is, or pods, which is our front end and back end. If I then go ahead and change my replicas to 2, for example, let's change front end and back end to 2, and then I run kubectl apply again, you're going to see that there is indeed a configured option that has been passed for my deployments. So now when I run kubectl get pods namespace app, you're going to see that I have 2 containers being created, and I have 2 versions or 2 replicas of my apps. So now if I run kubectl get deployment namespace app, and we're going to do everything with -n app because we're referencing the namespace of app, you're going to see we have a backend deployment, a front-end deployment. The same thing if we get services. So like I said, we deployed a service as well. And you're going to see we have a cluster IP and a load balancer. Load balancers are obviously going to be a little bit different. And you're going to see that this external IP is pending, so we can't actually access it right now. Now, why is that? It's because with Minikube, in order to actually access this, we need to run Minikube tunnel. So what we're going to do is we're going to open a new app or a new tab in our terminal. We're going to deactivate conda because it always defaults that in my shell. And then we are going to run Minikube, and I'm going to bump this up a little bit, tunnel. And then I'm going to pass my profile of MLB roster, which is really my cluster, right? Remember when we looked at the profiles. So when I run that now, since it's running under sudo, it's going to ask for your internal machine password or your computer password. And then you're going to see now when I run get service -n app, my load balancer now has an external IP. So now how do we actually get the URL to reach our front-end service or our external IP? And run Minikube service profile equals MLB roster. The service name is front-end service, and then we're going to pass the namespace of app. Now what we get back is a URL, and it opens automatically. So you can see here that now we have our application. But if we get the roster, you're going to see we get our table and everything's all gravy. However, what happens now is that if I was to share this and I wanted someone from the internet to be able to use my service, they can't, right? Or maybe I want to have a custom domain for this. Maybe this IP is ugly, right? I don't want to have to go to an IP address. I don't want to have to remember this. Maybe I want to go to like seansrosterapp.com, right? So how do I do that? Well, that is where Ingress comes into play. So if you remember from our deployment file, we define our Ingress and we're saying, mark the host of seans-roster-app.com, and you can change this to whatever you want. But when we deploy this Ingress, now it's going to understand where to forward the traffic. And as I mentioned, Ingress oftentimes works with an Ingress controller. So what we need to do is we need to add the add-on for Ingress in Minikube by running Minikube add-ons enable Ingress -- profile and our cluster or my MLB roster. When I run this, you're going to see it updates and creates a bunch of different things. So when we see this is done and we can run kubectl get namespace, we're going to see that there's an Ingress nginx namespace. So when we run kubectl get pods -n Ingress nginx, you're going to see that there's now a controller running that allows us to forward this traffic and manage it or route it. So if I go into cd etc hosts or cd etc and then I cat my host file, you're going to see that I have this Minikube IP, which is my cluster's IP, routed to my Ingress domain or my Ingress host. So what I need to do from there is get my Minikube IP. Maybe mine's 192.168.64.2, and maybe yours is something different. It's going to be something different. So how do you get that? Well, if you run Minikube IP and then your profile equals MLB roster, you're going to see that you get an IP back, and this is what you need to put in your host file. So open your host file, maybe in Vim. I'm a Vim guy, but if you go down to a new line, hit the I command, or hit the I button and enter in that IP and then enter in that domain that you pass through in your Ingress resource in the deployment file. So now that we have that, we should hypothetically be able to go to seansrosterapp.com. seansrosterapp.com, and voila, it loads. But Minikube does not really allow you to expose things out to a masses, right? Like, it's meant for local development. If you were to run something like this, honestly, I'd recommend you do it using a cloud environment, especially if you're actually starting a business and you're looking to like have a production ready environment. I don't think Minikube's the way to go. You're going to eat up your resources on your computer because it runs on a hypervisor. In this case, you could run on like Docker desktop driver, but ultimately I don't think it's a good idea. So what I would do in this case to be able to get this out to the internet is use something like ngrok. Now, ngrok's a great tool because it can be open sourced or you can pay for it. In this case, we're just going to show you the free version. So create an account. In my case, I already have an account, and you can see that it detects what OS I'm on and gives me commands to run. So the first thing I'm going to have to use is Homebrew. If you haven't installed Homebrew, watch a lot of my videos. I think we use Homebrew in almost every one of them. So let's get out of this, and then let's run brew install ngrok blah. So we do that. It's going to take time. I already ran it, so I'm not going to bore you guys. Then I'm going to add to my configuration my authentication token for ngrok. And then you're going to see that I can deploy my app online. But what this is saying is it's an ephemeral domain. So pretty much every time you quit this and rerun the command, it's going to spin up a new ngrok URL for you. So like, let's just take this example and let's just run this. You're going to see that it understands my Gmail because of the authentication I passed it. And then it's also going to give me this forwarding URL for this free app, right? And this has a unique identifier, CBB1, blah, 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 blah. Now, if I close this out and run it again, watch, it gives me a new one. And this is what it means by ephemeral. Almost like pods in Kubernetes, when they die and spin up, they're going to have a new unique identifier. Same thing with ngrok in this case. So how do we actually get this to point to our application, right? So we did that. Remember, we modified our hosts, our etc host file to be able to point our Minikube IP for a cluster to an actual domain that we want. So what we're going to do in this case is we're going to run ngrok, and then we're going to say http --host--header equals that URL we passed from our Ingress, and then we're going to say seansrosterapp.com, which is where we want to route, and then we're going to go port 80 because that is where we are going to direct traffic to, which is port 80. So if we run this now, you're going to see that it gives me a free app, and it's going to say it also directs the traffic to seansrosterapp.com on port 80. So let's run this, and you're going to see that it says you're about to visit this website, blah, blah, blah. It's free. You visit the site, bang, it works, right? Select the team, it works. So now what do we have, right? We've taken an application from what we have in Python and JavaScript. We've bundled it in a Docker container. We've now deployed it in Kubernetes using Minikube. We've forwarded it to a domain that actually is human readable and isn't some IP. And now you can take this and really do whatever you want. I recommend you mess around with cloud environments. It's really the now. Everyone uses it in production. So guys, I hope this helps. I hope this gives you some foundation. And that's a video. I will see you in the next one. Take it easy.